atomic radii, which is nothing but a distance from the center of the nucleus to the outermost shell of an atom. What is ionization enthalpy? It is the energy which is required to remove the electron which is present in the outermost shell of a gaseous atom. The energy is required to remove the first electron. It is very easy, but energy is required to remove the second electron will become very difficult. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called D and F block element. Under that, we have discussed about the general introduction to the D block, and in that D block, we have learned what is transition series. So, in the transition series, we have understood that there are 4 different series will be there, that is 3D series, 4D series, 5D and 6D series in the D block element, and also we have learned about the general electronic configurations of the D block element, and also we have discussed about some of the important characteristics of the D block. Today, let us move on to the next topic of this unit by understanding general characteristics of the transition element in terms of atomic radii, ionic radii, and in terms of density. And in addition to this, we are also going to discuss with the trends in the properties of the transition element. In that, we are going to discuss about the metallic and ionization enthalpy. So first we will see what is a atomic radii. So already in our first PUC, we have understood that atomic radii, which is nothing but a distance from the center of the nucleus to the outermost shell of an atom. Is it right? Yes. So as we move along the period in the periodic table, I am talking about only the D block element. As we move left to right in the periodic table, let's see what will happen to the atomic radii. Okay, atomic radii of the elements of a given series will be decreases with increasing in atomic number, but this decreases will become small after the midway. So as we move left to right in the periodic table, what will happen to the atomic radii? It will be started decreasing due to the increasing in nuclear charge. Is it right? Yes. And also, you can see that as the number of atomic numbers which is increased, the same number of electrons are added to the last shell. Due to this, there will be a increasing in the nuclear charge, so that the distance from the center of the nucleus to the outermost shell will be get decreases, so that atomic radii will be get decreases in terms of D block also. But when we are looking at the series, especially I am talking about 3D series, at the beginning it will be started decreasing, but later on that pathway, few elements are shows its atomic number decreasing in the nature, almost all in the midway, it will be almost their atomic numbers will be similar, and there will be a sudden increase in atomic numbers will be taking place. So this is one of the speciality of the D block element when we are understanding the general characteristics of the transition element. So in the first transition series, atomic radius will be gradually decreases from scandium to chromium, but thereafter it nearly the same. So as I have told you once again, remember we have discussed that in the D block element. Okay, as we move from scandium to zinc, especially from the scandium to the chromium, this atomic radii will be started decreasing. Thereafter, it shows nearly the same atomic radii. Then afterwards, there will be a sudden increase in the atomic radii will be observed in case of the D block elements. We will see what is the reason for that. So, in the beginning of the series, the screening effect or shielding effect of the D block electron is not that effective. Hence, the net electrostatic force of attraction between the nuclear charge and to the outermost shell of the electron will be get increased. Hence, their atomic radius will be decreases. So, as we move left to right in the periodic table, I am talking about the first transition series, that is in a 3D series. If I move from scandium to the chromium, due to the number of electrons are added to the same shell, their atomic radius will be started decreasing because of the increasing nuclear charges. Okay. Thereafter, in the middle of the series, there is an increasing in the nuclear charge, so that there will be increasing in a screening effect which balance with each other, so that atomic radius are become almost constant. So thereafter, what will happen after the chromium? Their atomic radii as well as their atomic numbers will be almost become very similar. Due to this, the shielding effect as well as the electrons which is present in the outermost shell will be get balanced, so that atomic radii will be become almost similar with the few elements. Thereafterwards, there will be a sudden increase in the atomic radii towards the end due to the electron-electron repulsion, which causes a expansion of the electron cloud. Thereafter, which means to say that after the zinc, or if you take the zinc as such, we know that the zinc which is having the electronic configuration of argon 3d10 4s2. Is it right? So it consists of 10 electron in the last shell, that is in the 3D shell, so that all the 10 electrons which undergo repulsion, because the same electrons will be going to add to the last shell. Is it right? Yes. Due to this electron-electron repulsion, there will be a sudden increase in the atomic radius will be taking place in case of the D block element. So, we will understand more about this by looking at this graph. So, from this graph, you can clearly understand that this is my first transition metal that present in a 3D series, that is scandium, then titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. You can see now, so from the scandium to the titanium, you can see that atomic radii will be started decreasing. Thereafter, you can see that from after the chromium, you can see that the manganese, iron as well as with the nickel, they shows a similar, or you can say that their atomic radii are very closer to one another. Okay. Thereafterwards, you can see that from nickel to copper, there will be a sudden increasing in a atomic radii will be taking place due to the electron-electron repulsion. As we have understood that zinc will be having the electronic configuration of argon 3d10 4s2. Similarly, copper will having argon 3d10 4s1. Okay. Due to the electrons which is added to the same shells, the electrons repulsions will be taking place, so that there will be a sudden increasing in the atomic radii will be taking place as we move left to right in the periodic table. So, similarly, I have shown with the 4D as well as with the 5D series. Next, we will see what will happen as we move down the group. So, as we move along the period from the left to right, we have understood that atomic radii will be decreases up to the chromium. After that, it will be nearly same. After that, there will be a sudden increase in atomic radii. We'll see what will happen as we move down the group. So, atomic radii will be increases while going down in each group. However, the third transition series from hafnium onwards, the elements have an atomic radii nearly equal to those of the second transition element. The reason is, this is due to the introduction of the additional shell to each of the new element down the group, and nearly equal radii of the second and third transition series will be taking place. This is due to the special effect known as lanthanide contraction. This is very, very important. As we move down the group, as we are already understand that because of the number of shells which is increases, there is a distance from the center of the nucleus to the outermost shell will be increases. Due to this increasing in the number of shell, atomic radii which is also increases. But during that pathway, especially after the hafnium, that atomic radii will be almost become similar. This is because of the lanthanide contraction. So more about this lanthanide contraction, I'll explain you in the F block elements. Okay. Now you can see that the zirconium, which is having the atomic radii around 160 picometer, then hafnium, which is having 159. Similarly, molybdenum, which is having 164, and similarly, vanadium, which is having 139. Similarly, you can see with the cadmium as well as with the mercury. So, all these elements, they shows similar atomic radii after the hafnium. Okay. Next, we will see what is the ionic radii. So, the ionic radii follow the same trend as that of the atomic radii. For the same oxidation state, ionic radii will be generally decreases as the atomic number increases in a particular transition series. For the same element, ionic radii will be decreases with increase in a charge of the ion. So, we can understand this ionic radii by taking the example of the iron. We know that iron will be exists in a +2 oxidation state as well as in a +3 oxidation state. Suppose if you see that if the oxidation state of the iron is +2, then ionic radii will be 76. If it is exists in a +3 state, it will be decreases to 64. Okay. Similarly, you can see with the nickel, if it is exists in a +2 oxidation state, it will be exhibit in a 72 picometer. If it is an +3 oxidation state, it will be decreases to 62 picometer. Similarly, with the manganese 80, and if it is in a +3 state, it will be 66. This indicates that when the elements are exposed in terms of oxidation number, their ionic radii will be decreases even though oxidation state will be decreases or increases. Okay. Next, we have one more property, that is density. Okay. So, all the metals have a high density within a period, and the density will be vary inversely with atomic radii. Density will be increases along the period, and density will be increases upon the descending order in the group or down the group. So, as we move left to right in the periodic table, the density will be increases because of the increase in atomic number. As we are already understood that this D block elements are nothing but metals. Even though they are nothing but metals, they are very hard. Is it right? That is why their density will be also high because of the high mass. Is it right? Yes. That is why as we move left to right in the periodic table, the density will be increases. But as we move down the group, the density will be decreases. The reason is atomic values of the transition element are low because of the electrons are added to the n-1d subshell, not to the ns subshell. Therefore, increased nuclear charge is partially screened by d electron, and outermost electrons are strongly attracted towards the nucleus. However, the electrons are added to the inner shell. Consequently, the density which is also become very high. As we have already understood that while writing the general electronic configuration, so it is n-1 d ns2. So first we will fill the electron to the ns, then we will fill the remaining electron to the inner shell. Hence we call this d block element as a penultimate shell. Is it right? Yes. Due to this reasons, when the electrons are added to the inner shell, the density which has also become very high. Next, we have a trends in the periodic table. First, I'll go with the metallic character. So, already I have discussed that this D block elements are nothing but metals. So, we all know that if the substances are behaving like a metals, it will be usually very hard and it having a luster nature, which means to say that it will show a shiny appearance, And also, all this metal which is having high conductivity in terms of thermal as well as with the electron. Is it right? So, they are the very good conductor of heat and electricity, and also they are malleable as well as ductile in nature. Let's see what are the metallic characteristics of the D block element. All the transition elements of the first row are metals, and they exhibit typical metallic characters such as metallic luster, high density, high melting point, high boiling point, malleability, ductility, and high tensile strength, hardness, and also they are brittle, and also they have high thermal and electrical conductivity. In addition to this, they also exhibit all the three types of the structure. So, as we have studied in case of the solid state, that is the first chapter in your second PUC. So, if the substances, if it is a metal, they exhibit in a solid state. Is it right? Yes. And it has a three different types of structure. They are cubic closed packet structure, then hexagonal closed packet structure, and body centered cubic structure. You can see here, I have represents the 3D series. This is a 3D series. Okay. You can see that the scandium will be shows the HCP structure or with the BCC. Similarly, the titanium which shows both HCP as well as with the BCC. Similarly, with the vanadium which shows the BCC, or with the chromium which shows BCC, and whereas the manganese which shows SCP, and irons which shows the BCC, and cobalt which shows the CCP, whereas the nickel which shows CCP, and copper which shows CCP, whereas our zinc which shows what? HCP. This is how, even though it is behaving like a metal, which shows the different characteristics as we have studied in case of the solid, which shows the all the three different structures. Okay. Next we have ionization enthalpy. So, when you are studying with the classifications of the elements and periodicity in the property in your first PUC, so you also understood that what is ionization enthalpy. So, what is ionization enthalpy? It is the energy which is required to remove the electron which is present in the outermost shell of a gaseous atom. That energy what we require to remove the last electron, which is known as what? Ionization enthalpy. Is it right? Yes. So, the ionization enthalpy increases in the series and the atomic number will be increases. However, the increasing is not a regular. This is because of the effect of increasing a nuclear charge, which is somewhat neutralized by the increase in a shielding effect of the 3d electron. So, in a group, ionization enthalpy will be increases from left to right. For example, you can see that I have represents the 3D series from the scandium to the zinc. You can see that the first ionization energy. What is mean by first ionization energy and second ionization energy? As we have already understood that first ionization energy, which is nothing but energy is required to remove the first electron. Is it right? Whereas second ionization energy indicates that energy is required to remove the second electron. Is it right? Yes. So, you can see that as we move along the left to right in the periodic table, then ionization energy will be also increases from scandium to the zinc. You can see that from the scandium it has 631, titanium which is having 656, and vanadium which is having 650, whereas chromium which is having 652, whereas manganese which is having 717, whereas iron which is having 762, whereas cobalt which is having 758, whereas nickel which is having 737, and copper which is having 745, whereas the zinc will be having 908. There will be a sudden increasing in a ionization enthalpy. So, the ionization enthalpy for the scandium, vanadium and titanium and chromium, which is almost closer. Is it right? From the scandium to the chromium, you can see that it will be fall around 600 ranges, and similarly from the iron to the copper, you can see that these are the values which is found around 700 region. So, this shows that the first and second ionization enthalpy of the transition element, as we move left to right in the periodic table, it will be get increases. The slight variations which occurs in this value mainly due to the slight changes in the atomic radii. Why the slight changes will be taking place? As we have understood that the atomic radii will be started decreasing, but there afterwards in that midway, it will be almost closer to each other and there will be sudden increase in the atomic radii. Because of that reason, there will be a slight changes which is also there in the ionization enthalpy. And we have to understand more about the following things here. The value of first ionization enthalpy for the chromium is lower than that of the expected one. This is because of the removal of the one electron which is produced due to the extra stable d5 configurations. As we have seen from this, the chromium which is having 656 ionization energy. Is it right? So, but it is usually very lower than that of the expected one. That is mainly because the energy is required to remove the first electron. It is very easy, but energy is required to remove the second electron will become very difficult. Then the value for the Zn, that is for the zinc, is applicable higher due to the additional stability association with the completely filled 3d10 inner zinc. We know that zinc will be having the electronic configuration of the organ 3d10 4s2. Is it right? So when we remove one electron from the 4s, still there will be one more electron. So energy is required to remove the second electron, which is also become very less. But you can see that there afterwards, even though when you are removing first and second electron, it shows the stable electronic configuration. You can see that in case of the chromium, if you remove the one electron from the 4s, still there will be a 5 electron in a 3D. This indicates that once you remove the electron from the 4s, still there will be a 5 electron in the 3D. So that energy is required to remove the 5 electron from the 3D series is very difficult. Is it right? That is why they require higher energy as it is compared with the first ionization energy. Similarly, this will be applicable for the copper as well as with the chromium. So, the value of second ionization enthalpy for the zinc is comparatively lower as this involves the removal of the electron which results in a production of Zn2+, which is having the stable 3d10 configuration, and second ionization energy of the manganese is less than that of the iron because of the removal of the second electron from the manganese produces the half-filled d5 configuration. So first I will write for the manganese as well as for the iron. Okay. So it is argon 3d . So when you are looking into the electronic configurations of manganese as well as with in case of iron, the electronic configurations of the manganese is argon 3d5 4s2. Similarly for the iron, it is argon 3d6 4s2. So first if you remove one electron from the 4s, still there will be one more electron so that it can easily release. But if you wanted to remove the electron which is present in the 3d, so it will be requires higher energy as it is compared with the iron. So this indicates that even though when you are applying the energy to remove the first electron from the outermost shell of the d orbital, it is very easy. But for removing the second electron, we need to apply more energy. Hence, their ionization enthalpy will be increases as we move left to right in the periodic table. In the next session, we are going to discuss with the oxidation states of the D block element. By this, I like to say that what are all the things which I covered in this session, have a look on it, because most of the time they have asked the trends in the periodic table, especially for the D block element. You have to look into that and make a note and work out hard. We'll meet you with the next session. Till that, take care, be safe. Thank you.